Hi everyone, my name is Jaewoo Choi and I'm a student at Sunny Hills High School. Today, I'll be presenting on structural characteristics and toxicity of PFECAs and 6-FTS in marine organisms. In this presentation, I'll be exploring their structural properties, toxicity level, and environmental effects. Let's begin. Here's what I'll be covering today. First, I'll introduce PFAS, highlighting their properties and concerns. Then I'll provide an overview alternative explaining how they are engineered. Next, I'll focus on PFECAs and its toxicity, followed by an analysis of 6-FTS and its toxicological profiles. I'll also discuss the structural characteristics and their effects on toxicity. Finally, I'll highlight key research gaps and conclude with an overall evaluations of PFECAs and 6-FTS as PFAS alternative. By the end of the presentation, I hope to provide a clearer understanding of real-world implications of these chemicals and whether they truly serve as a safe alternatives. PFAS are synthetic chemicals that contain strong carbon-fluorine bonds, making them resistant to heat, water, and oil. However, their persistence in the environment has raised significant concerns. They're often called forever chemicals because they do not easily break down, leading to accumulations in human bodies and organisms. Studies have linked PFAS exposure to health issues such as cancer, immune system suppression, or hormonal imbalances. My motivations for this topic stems from my volunteer experience, where I wanted to provide safer environment for children. While alternatives have been developed, the key question still remains. Are these alternatives truly safe? As concerns about PFAS grow, researchers have been working on safer alternatives. But how are these alternatives engineered? To reduce persistence and toxicity, researchers modified the chemical structure of traditional PFAS. This includes adjusting the carbon chain length to improve degradability and reduce bioaccumulations. Introducing new functional groups such as ether linkages or sulfonate groups to alter their interactions with biological systems is also a way to reduce harms. Now let's take a look at two alternatives. How are PFAS, PFECAs, and 6-FTS specifically developed? PFECAs are compounds that contain ether linkages and carboxylic acid groups, which improve degradability and reduce accumulations. 6-FTS are developed by modifying fluoroatomic structure and adding a sulfonate group, balancing hydrophobic and hydrophilic properties for effective surfactant behavior while aiming for lower toxicity. The goal of these innovations is to develop chemicals that retain industrial effectiveness while being less harmful to the environment. But have these goals been fully achieved? Let's take a look at their toxicity. When evaluating toxicity, we look at EC50 values indicating the concentration at which a chemical affects 50% of a test populations. This means a lower EC50 values mean higher toxicity. Among PFECAs, PFO5 DODA indicates the most toxic with an EC50 value of just 22.9 milligrams per liter. ECO3OA is least toxic with an EC50 value of 1,227.4 milligrams per liter. This suggests that small structural differences significantly influence the body and the toxicity. PFECAs consisted of perfluorinated carbon chains with ether linkages and carboxylic acid groups. They can be classified into long chain and short chain variants. Long chain variants means there is more than 8 carbon chains, where low or means that there's less than 8 carbon chains. Despite these modifications, PFECAs still persist in the environment, raising concerns about their long-term effects. Specifically, strong CF bonds confer higher resistance to degradation, leading to prolonged environmental presence. Now let's take a look at 6-FTS. Noel values show that PFOS is much more toxic than 6-FTS. However, 6,2-FTS still accumulates in marine organisms. Its long-term effects remain unclear. Some structural differences are that PFOS has a fully fluorinated chain with a sulfonate group. 6,2-FTS has a 6-carbon perfluorinated chain linked to additional carbon chains with a sulfonate group, which concludes that it has low toxicity than PFOS. Although PF6-FTS appears less acutely toxic, its long-term accumulations and potential endocrine effects raises concerns. However, does this really mean that 6,2-FTS is better than PFOS? To answer this, we need to explore its chronic effects. Even though acute toxicity tests suggest 6,2-FTS is less harmful than PFOS, long-term effects could still be dangerous. Some key concerns are chronic exposures may cause endocrine disruptions or developmental toxicity. Bioaccumulation could still occur, especially in marine organisms. More research is needed to understand long-term risks of its environmental impact. Some ways we can do some more research to 6FTS could be multi-generational research, researching all the generations of specific marine organism. Now let's take a look at the relationship between structures and toxicity. PFECAs are longer linear chains include bioaccumulations and toxicity. Variations like branched versus linear structures affect persistence. 6,2-FTS has 6-carbon fully fluorinated chain with a sulfonate group. While acute toxicity appears lower, chronic exposures may lead to hormonal and reproductive issues. Understanding the structure-toxicity relationship is very essential for assessing risks. Now let's take a look at research gaps. Despite these ongoing studies, significant research gap remains. Long-term toxicity data for 6,2-FTS is lacking. Comparative studies between PFECAs and 6,2-FTS are limited. The impact of PFAS degradation products is unclear. Following these research gaps, we can conclude that future research should prioritize developing predictive models for bioaccumulations. Expanding those long-term studies in marine species is also crucial. Finding safer structural modifications to balance effectiveness and safety is the main key point that researchers should focus on in the future studies. Now let's take a look at the conclusion. In conclusion, PFECAs and 6-FTS were designed as safer alternatives. However, each exhibit unique structure features that affect their environmental behavior. 6-FTS shows relative lower acute toxicity compared to PFOS. However, the potential cumulative effects and endocrine disruptions remains a concern. PFECAs, especially long-chain variants, raises significant environmental risks. A deeper understanding of structure and toxicity relationship is essential for developing truly safe alternative for PFECAs. Thank you for listening.